So let's continue with activity 1.9 through 1.11 with problem 4. So here we have a salesperson earning a weekly salary of $350 plus 2% of her total sales for that week. So in this situation, weekly sales will depend on total sales. Weekly salary will depend on the total sales for the week. The independent variable would be total sales, and the dependent variable would be the weekly salary, right? Because the weekly salary depends on the total sales. So the input is the total sales, and the output will be the weekly salary. Then it says the equation y equals 350 plus 0.02x gives salary y, where x is the sales for the week in dollars. Right? And this should make sense, right? It's the 350, there's my 350, plus 2%, there's my 2%, times total sales, so times x. X would be the total sales. Then there's a paragraph that talks about the domain and the range of this function. And they say, the domain could be all real numbers because we could use any value for x, and the range could be all real numbers because we could have any value for y. And if you remember up here, it says the collection of all possible values for input is the domain. So that's all values for x would make up your domain, and your range would be all values for y. However, we want to consider the practical domain in this case. So if we take a look at the table, right, the input, it goes from 0 to 10,000, right? So your input, remember, that was your total sales. So I'm just going to write that on the side. And the output was your weekly salary. So the practical domain, the values of the input that make sense, a lot of times I like to take it right from the table. And it looks like the input goes from 0 to 10,000, so I'm going to use that. And we can write the practical domain with an inequality symbols, right? Here we're going to say that x, or the total sales, is going to fall somewhere between 0 and 10,000. And it looks like her weekly salary, or y, is going to fall between $350 and $550. So again, when dealing with practical domain and practical range problems, many times it's helpful to look at the table if one's provided. Let's take a look at problem 9. At a particular car rental company, the cost of rental depends on how many miles you drive. Then we're asked, what is the independent variable or input in this situation? And we're asked to give it a variable name. So we're going to say the number of miles driven is the input, and I'm going to call that n for number of miles. And the dependent variable will be your total cost, right? Your cost of rental. So I'll probably call that C. And then we're asked to fill in the blank with words. So I'll say cost is a function of the number of miles driven. Then we're asked to write the functional relationship with the appropriate variables. So the variables I used were the n and the c. So you can see I've written cost is a function of the number of miles driven. Number 12 says, okay, well, let's say it's $60 a day to rent the car plus 10 cents per mile driven. Write the equation that relates the cost and number of miles. Right, so still, cost is a function of the number of miles driven. And in this case, our equation will look like this. Right, there's my $60 plus the 10 cents times however many miles I drive. Question 13 says, use the equation above to find f of 250. All right, so I'm going to replace the n with 250. So here's my equation. The $60 plus 10 cents times 250 miles leaves me with $85. Let's go down to number 14. It says the graph below relates the cost of the rental in the miles driven. It says label the axes with words and correct variables, then answer the questions. So here are my labels. The first question says, what is the domain of the function? Now this is tricky. Notice how the next question says practical domain. So the domain will be all real numbers, but the practical domain, in the context of this problem, well, just looking at the graph, looks like you can go from either 0 miles to, say, 600 or 650. maybe say 700. Note the book says there's many correct answers. I'm going to say from 0 to 650. So I wrote the domain using inequalities. Now for the range, again, it's going to be all real numbers. But the practical range, we're going to take from the table or from the graph. So it looks like, I don't know, it could be anywhere from 0 to 140 or 150. Some people might say, oh, well, the rental was $60, so maybe it should be from 60 to 140. People have different opinions on this. Again, many correct answers will suffice. I'm going to just say 60 to 140. And again, if you wrote 0 to 140 or 0 to 150 or 60 to 150, these are all correct. Notice I used N and C because those are the letters that we used here. If you used X and Y, that's fine as well. Just be consistent. Question 15 says, use the graph above to find f of 400. So that means our input is 400, and we want to find what the output is when the input is 400. So it looks like when the input's 400, my output's going to be 100. So the ordered pair is 400, comma 100. And the practical meaning, well, if I rent a car and travel 400 miles, then my cost is going to be $100. Moving on to the last few questions, it says, use this graph to answer the following questions. What is the value of h of 1? So again, my input is 1, and I'm looking for my output. So you can see when my input's 1, my output is 3. And the ordered pair would be 1, comma 3. Next, we're asked to find the value of h of negative 4. So the value of h of negative 4 would be 0. And the ordered pair would be 4, comma 0, right? Because when x is 4, the value of y in this case is 0. And by the way, I pointed to the wrong box. I pointed to 4, and they asked for h of negative 4. So here's negative 4 and the 0. It's still 0, but I have to just retype this down here. Not 4, comma 0, but negative 4, comma 0. Okay, I think I made that correction. Right? So the ordered pair would be negative 4, comma 0. And I'll put points on these ordered pairs. Now you can see my points a little more clearly. 18 says, on the graph above, mark the point 3, comma h of 3. So 3 would be my input value, or my x value. So here's my 3, comma 1. So I've marked that point. And I'll actually, they don't ask us, but I'll write the ordered pair another way. So I wrote this is 3, comma 1, or this could also be considered 3, comma h of 3. Right? Because if h of 3 is 1. Okay, and then the last question has nothing to do with the graph above. All right, it says consider the function n of t equals 2 plus 7t. So they say the input variable is, I'm going to say t. The name of the function is, I'm going to call it n of t. And the output is also n of t. Now we're asked to find n of negative 3. So really, we're going to replace the t with negative 3. So we have something that looks like this, right? 2 plus 7 times negative 3, which cleans up to be 2 plus negative 21, which equals negative 19. And then we're asked to write the ordered pair. Next, we're asked to find n of 0, and then the associated ordered pair as well. So really, not much changes with this equation 2 plus 7t, other than instead of negative 3 going into t, we're now going to place the 0 in for t. So we're left with 2 plus 0, or really just 2. And the associated ordered pair would be 0, comma 2.